Hey, this is Leach with Sims and Math, and in this video, we're going to be having to do a little bit of algebra to deal with finding a corresponding value of x when giving a mean, standard deviation, and a z-score. So first I'm going to try to paint the big picture, show you the algebra, and then I will show you how you can kind of backdoor it into Desmos. So first let me plop in a picture here real fast just so you can see what's happening. So we're told that there is a mean of 72.9 with a standard deviation of 3.85. And we're told that there is a z-score of 1.03. So basically, like right here, just barely above this, 1.03. And I want to know what this value is. And I'm going to use x to represent it. What is this x? We know the z is 1.03. The mean is 72.9, and the standard deviation is 3.85. So we want to know what that x is. So that's where this algebra is going to come in. We know about our z-score formula. The z-score formula is our z is our x minus the mean divided by the standard deviation. I'm avoiding any symbols, x bars or s's or mu's or sigmas, just so that way it's just nice and generic. So for this particular problem, we're told that the z is 1.03. And then I don't know my x. I'll put that in as orange, minus, and then we're told the mean is 72.9 divided by 3.85 for the standard deviation. So now all I need to do is to do a little bit of algebra. The good news about this algebra here is that it's always going to be the same for the same kind of typical pattern. So if I'm solving for this, x. Let me actually do a slightly different one, but just with some easier numbers. So let's say I have, let's just say 1 equals x minus 2 over 3. So let's solve this one. So I need to see what x would be. So to do that, I'm going to multiply both sides by 3. When I do that, this is technically a 3 over 1. And if I have a times 3 and a divide by 3, 3 divided by 3 reduces to 1. That's why I'm choosing to times by 3, multiply both sides by 3. And I can do this because I'm solving an equation, so I'm multiplying both sides by the same thing, which keeps everything balanced. So multiply both sides by 3, and then I have left on the left side just a 3 times 1 is 3, and then I have x minus 2 on the right-hand side. Just to be clear, this 3 divided by 3 became a 1. 1 times x minus 2 is now just x minus 2. That's why it kind of feels like it went away. It went away because it became a times 1. Times anything times 1 is itself, the itself being x minus 1 and x minus 2. Now we need to add this 2 over. So I'm going to add 2, and that's how we end up with 5 is our x. So in general, we're going to multiply by the standard deviation and then add the mean. Usually it's add the mean. The only case where it might not be an add is if for some reason the mean itself was a negative. Then this subtract a negative would have made this be a positive, and then in that case we would subtract the mean. But most often it'll be an add the mean. All right, so let's do the same thing. We're going to multiply both sides by, wrong tool, sorry. Multiply both sides by 3.85. I'm going to come over to Desmos and type in 3.85 times 1.03, and I get 3.9655. I'm going to change this out of that green and back into 3.9655. Now I'm going to then, what am I doing? Sorry. This right-hand side, it should be x minus, I got obsessed with colors and started writing the wrong thing, x minus 72.9. So let me be clear, back up a second. I multiply both sides by 3.85. Why am I doing that? Because 3.85 divided by 3.85 is 1. And on the left-hand side, 3.85 times 1.03 is 3.9655. And we have left over, these have reduced to 1. And left over, I have x minus 72.5. Like we said a second ago, multiply by the standard deviation. Now we're going to add the mean. So I'm going to add 72.9. And this 72.9 minus 72.9 adds to 0. That's why that works. And x plus 0 is just that x. And when I add these two things together, we end up with 76.8655. Or rounding, according to what MyLab wants, they want this to round to 76.9 to the nearest tenth. So you can see how I did this on MyLab, on Desmos here. I could have taken the number that I had, the 3.9655, and add the 72.9, but I went ahead and just added it to this previous math step. Since I'm multiplying and then adding, I don't have to worry about parentheses for order of operations. So I'm just multiplying z times the standard deviation and then adding the mean. All right, let me show you what's happening with, let me show you a different way to get this. And this is using Desmos. Like I said, I'm going to kind of backdoor my way into this. So I'm going to put up two normal curves. The first one I'm going to put up is just our mean of the standard normal distribution, mean of 0 and 1. Going ahead and typing in 0 and 1 because I want to see them here, 0 and 1. Then I'm going to put in another one. This I'm using my mean of 72.9 and standard deviation of 3.85. So 72.9 and 3.85. So what I'm wanting is I'm wanting to find where, when you have a z-score of 1.03, where that falls on this one. Let me change it. This is purple. Let me change this to orange. So I'm going to see when I'm on the orange one, I want it to be the same spot as it is in the purple one. I can't really show them at the same time because they're like really far apart from each other. So this is the orange one. This is the purple one. I can't really show them at the same time. All right. So I'm going to go to my standard normal, which is what the z-score is, and put in it doesn't matter whether it's left or right. I'm just going to do area to the right because I'm on a positive value. So area to the right of 1.03. And when I do, I get 15.2. Let me go ahead and export that so I can get a whole bunch more numbers. So I get all these values. So this is the area to the right of my z-score. I'm going to come over here to the normal curve of in context. I'm going to do the same thing, almost the same thing. I'm going to make it be the right, but this time, instead of inputting in my area, or so instead of inputting in the bounds and computing the area, because I don't know those, I'm going to input the area and output the bounds. So I'm going to put in an area to the right. So I'm going to put in the area of 0.512. I'm going to go ahead and paste because I've copied this number. I'm going to put in the area of 0.151505002788. I'm putting in all those numbers right here. So this is the area to the right of some value. What is that value with this mean and standard deviation? Well, that's 76.87 or 76.8655, which is, let me put up my work. That is 76.8655. That is literally what we just found algebraically. So let me switch between these two. Just want to go to purple to orange, purple to orange. That shaded region is the same. This first one, the purple one, I knew my input, my z-score, the number on the x-axis, in this case kind of z-axis. The number on the x-axis of the purple has an input of 1.03. I want to find that same relative input, but on this orange one. Well, to find that same relative input, I'm going to put in the shaded area here of about 15% here into the orange one. So when I put in the shaded region, this orange one, this 0.15% up here, not 0.15%, 15%. ish up here on the right, it gives me the corresponding x value of 7687. All right, we had this again. Just another one to practice. A normal distribution has a mean of 53.8 and standard deviation of 3.65. Find the data value corresponding to a z-score of negative 3.01. So I'm going to stop for a second. I'm going to give you, I'm going to do this just a second, but I want you to go ahead and pause the screen and try it on one of the methods. So do it the algebraic method, or do this the screen method, the Desmos method. All right, hopefully you've paused it and done it. I'm gonna go ahead and I'm gonna do both ways. So algebraically, reminder, we have our z is equal to some x minus the mean divided by the standard deviation. We're told that the z is negative 3.01. I don't know the x, I'll just leave it as x minus the mean of 53.8 divided by the standard deviation of 3.65. If you need a little bit of a nudge, try to solve it from here. As we discussed earlier, we're going to be multiplying by the standard deviation first. We do need to be mindful of our signs. So when I do my multiplication here, I'm going to get 3.65 times a negative 3.01. A positive times a negative is a negative, so do be careful about that. So I get a negative 10.9865. Let me write this down and then I'll swap it so you can see it. Negative 10.9865. And that's going to equal this numerator over here, x minus 53.8. And then I'm just going to add this 53.8. And when I add the 53.8 plus 53.8, we end up with 42.8135, which is the 42.8 here. So just finishing up my math. 42.8135 is my x, or rounding it, we get 42.8. All right, or we can do what we did a second ago. So I have my normal distribution here. I'm going to go ahead and change. I have my z-score one up top in purple. I'm going to leave my orange one to be the number in context, 53.8. The mean standard deviation 3.65. I'm going to find the area. Just to be clear, I'm going to do the, let's go to the purple. I'm going to do the area to the left of negative 3.01, which is going to be a really tiny number. Like I can maybe zoom in and we can see it. This is really tiny shaded piece right here. It's really small. So I switched to left just because. And we get a really, really small shaded region, something that is just barely bigger than 0.1%. So I'm going to come to my orange one, switch it to left, and if this is left, this is left, they need to be the same. Change my input to be our 0.0013. Especially in something this small, you will probably want several decimal places. And when I do, I get 42.8, which is what we're looking for. So whether you do it algebraically or kind of conceptually here, I don't care. I kind of like the conceptual way here in Desmos because I think you're understanding what's happening instead of just being some magic formula that's happening. I feel like if you're doing it this way, you might understand why this z-score of negative 3.01 corresponds with this x value of 42.8 under this normal distribution. All right. I hope this helps. For my contemporary students, this was question 22-23. For other people, hope this helps you maybe in a stat class or something. All right. Take care, and I'll see you all in the next one. Bye.